these last two levels. We'll still stick with the snap the dot activity, but we'll show how we can demonstrate the necessary skills so that we can get the third and fourth levels sort of measured against as well. And I think if you look at both the third and the fourth levels, it's almost identical opening statements that they've got, and we can pick out some of these keywords such as what we've got. We've got design, we've got build, we've got evaluate, and then we've got that new one that says refine.
Lovely. So if we key on that first word you said there, so design the game, we're going to have some sort of graphical notation for that. Now, a flow chart could be used to design this code. At the top right-hand side of the corner will show you how you could design a solution for the movement of the sprite, with each box representing the process and the arrows indicating which process followed it. So sort of starting at the top and working our way down to show the flow of that program.
And again, that might probably be very detailed, but what we can introduce to them is just that whole concept of a flow chart where you've got one process and it's the arrows that we really want to try and sort of make most important to the pupils. If we're talking about the arrows, it's all about that process. What comes next? Do we go this way? Do we go to the next? It's all about trying to get pupils to understand that, improve their computational thinking. So another design notation that we could use is if we focused on the microbit itself, we could use a wireframe. So down at the bottom right-hand corner of your screen, just underneath the flowchart, we've got a sketch of the microbit. So we could print that out, and then we could give this to pupils, and maybe using coloured pens or coloured pencils, we could get them, without actually looking at a microbit and creating it, we could try and get them to imagine how we want that game to work. So if they could try and then illustrate it or annotate it to try and explain in their own words before they actually go and create it, how do I want this game to work?
Lovely. So when we're actually building the game itself, the benchmarks do explicitly indicate a visual language can be used for the third level, but a textual language does have to be used for the fourth level. Yeah,
so that's when we would have to try and use something which could be Python, but that's the reason why we've sort of included that down at the bottom left-hand corner there. So again, the reason why we're choosing this activity is that on the Microbit website, it takes you through step by step how you could do this using Python, which I think is quite important, because this will be a tricky concept for them if they were to progress and continue with computing science out with BGE. So if you can maybe get a tutorial that will take them through step by step, you don't want to scare them off, you want to try and show them hopefully how they can achieve effectively the same thing, but with a programming language that's going to be more beneficial to them when they move through the school. So Python would open up the possibility of making the code much more complex for any of those pupils that are probably eager to do so.
Yeah, so the benchmarks in the fourth level do require the pupils to know about variables, logical operators, selection. So we could use the altered scoring system from the previous slide to create a pretty effective solution to cover that. So at the bottom of the slides, part of the scoring system would make use of the logical operator, or to compare the x coordinate, and if it matches either value, it can simply just update that variable score that we had from earlier.
And then we're moving on to the refinement part as well. So that involves breaking down a specific step into a lot smaller steps as well. And usually, for some reason, all computing science teachers seem to do this as well, but whenever it comes to refinements, we always seem to talk about making cups of tea, and it's all about breaking down one step into all of these different many steps. And for whatever reason, the scenario that we always seem to try and demonstrate to our pupils is always about cups of tea. So in this case here, if we were talking about it in terms of creating the sprites, how can we break that down into even smaller parts? So if we were wanting to create a sprite, the first thing that we would have to do is we would need to initialize, which is basically set up the sprite in our code. And then we want to be able to set up the x coordinate to be 2. And then we can set up the y coordinate to be 2 as well, so that it appears right in the middle. But that would be an example of maybe taking just one step and then trying to get the pupils to understand are there many steps involved to try and set up that first step for us.
Yeah, I might need to get your cup of tea recipe for after this corner, see how we get on. So we could continue to use the same evaluation methods from the previous slide, the fourth level, but we'd look to link it more with the testing of the game. Your pupils could possibly look at producing a report that would outline the tests that they undertook, what they expected to happen, what the result of the game was, and evaluate the impact this has on their game. So we're thinking about it very, very similar into what we were talking about at that evaluation stage in the past, a little bit more detailed than what we're looking for.
Yeah, so the only difference between the third and the fourth is that additional requirement in there where it says that we're wanting to process and present information while making reasoned arguments to justify decisions. The benchmarks they sort of indicate a couple of things that we can do to try and get that bit completed.
So there are probably three statements that match up with the statement. The probably three best possible ones are: the develop a relational database to represent the structured information. You could compare common algorithms, for example, those are sorting and searching, and justify which one would be the most appropriate for their given problem, or simply just design and build a web page which includes some interactivity.
Aye, so they're quite detailed benchmarks that Ryan's just mentioned. And the first and the third, they involve a lot more than we've discussed over the two sessions, not just this one tonight. But the second benchmark is probably the one that we can demonstrate here. So that second benchmark where it's saying that we have to be able to compare common algorithms. One of the common algorithms that we could maybe use then is the running total. So that one there that we've got just underneath the word wireframe, where we've got score is set to score +3. That's one of the algorithms that's taught when we move from BGE into your nationals. So that could possibly be one that we could use from this activity here that would effectively measure how well we've completed the fourth level. So hopefully, and again, it's quite a lot that we've went over there, but hopefully it makes it just a wee bit easier to try and understand how you're referencing against these different levels, and more importantly, how you can distinguish between your two different levels as well. Obviously, some of the activities that we've done might be able to go straight into possibly like a level 2. But if there's any feedback at all that you can get from those slides that we went over, but maybe even if you could share some ideas of how you in your school just now track pupils' levels against BGE, that'd be really helpful. And as well, we're obviously talking about these benchmarks as well, and I think they're probably going to update them fairly shortly as well. So we'll see how that works in future. But it's good to see your comments just now. I think it's probably going to be different between primary and secondary also.
Seen a few people that are talking about tracking and how it works or doesn't work where they are. It's definitely I think it's a concern for most practitioners, to be fair, especially when it comes to this. I think it's easy just to assume that, right, we've done that, move on, we've done it. But I think it's definitely worth taking that extra little bit of time to try and break it down, because like we're saying there, that's one task that's ultimately been spread across multiple levels, and with little tweaks, it's easy to see how your pupils are actually performing. So it's a little work at the beginning, but definitely pays off at the end once you're able to see that data.
I can see some of the ones we've got there. So traffic light systems with the benchmarks as well. Yeah, we use that. We use that in our school. Sometimes and again, that's sort of going on as well. What's the difference between sort of one who's probably going to be green, one who's going to be sort of amber? And I think that's sort of a good way of doing it, yeah. And then we've got the refinements as well used in S3, going over programming and design techniques. Yeah, use the same myself.
Yeah, definitely. I think there was since everyone's doing some really interesting and great things. I think it's just about sharing it and bringing it all in one place, and then trying to get improve what we have or tweak what's there. But
no, there's some good notes to have for the feedback. Thank you.